we're really interested in using high-dimensional phenotyping or phenomics to uncover the mechanisms of disease biology. And particularly, we're really interested in the biological mechanisms of genetic variants and mutations that are associated with both neuropsychiatric and neurodegenerative disorders. And we've been really interested in working with Element on their new technology because morphology is only one measurement. We have recently published this work on what we call neural painting, which is simply taking cell painting and then applying this to neural cell types. It's really easy in the lab, but the processing and analysis can really take a long time, and that feature interpretation that you get from that always requires follow-up experiments. So you have to then go measure RNA, you have to measure protein, and then try to understand which ones of those give rise to the morphological changes. And so the AVD24 platform allows us to capture all three of these simultaneously. And so we set up a pilot experiment with the AVD24 team where we took iPSCs from our lab, we differentiated these into both astrocytes and excitatory neurons. We grew these cells on the Teton flow cells. We would fix them, and then we sent them to Element for processing, part of the technology access program. Firstly, we're able to take the single cells and cluster them using the RNA expression transcripts with the AVD Neuro panel. But here, we actually get better accuracy, and we get the added information of kind of the RNA expression. So here again, we're just taking these clusters that we found using the gene expression information, but then layering on here values for the morphology features that seem to discriminate our cells. But one could easily imagine now going into each of these clusters and doing different kind of regression analyses to sort out whether there are specific proteins or transcripts that would associate with these morphological characteristics so that we can begin to draw linear relationships between protein and RNA activity and how cells change in response to certain contexts. You know, doing 1 million cells in a run is feasible, right? And having the data to come back after simply overnight, effectively, is really incredible. Sometimes I think it's hard to kind of grasp your head around rather than waiting weeks or months to get information on 1 million cells. You can kind of have it right away. The actual experimental part of it is incredibly easy. You just need to grow cells and fix them. In a system like this, where we can use many different dimensions to measure, at least in vitro, when things begin to change, that gives us a better sense of maybe what's causing disease rather than what is caused by disease. And so doing everything simultaneously, I think, could be really powerful.
Welcome to the 20-year anniversary video of Ingaba Biotech, Africa's genomics company, here from our headquarters in Makelnek, Pretoria in South Africa. I'm Dr. Oliver Preissig, a co-founder and the executive director of this unique company with currently around 150 employees in different countries in sub-Saharan Africa. The idea of Ingaba Biotech emerged not far from here in Pretoria in the year 2000 while I was doing research at the University of Pretoria and saw the need for this specific type of company in South Africa. It took 2 years for the venture team of 5 to officially start the business in August 2002, as it was a major struggle to find the funds to do so. The startup was only possible with the substantial direct foreign investments, mainly from shareholders from Germany and Switzerland, as well as the startup loan from the State Secretariat for Economic Affairs of Switzerland. So what was actually our idea in 2000 to start a biotechnology company in South Africa? The aim was to locally produce oligonucleotides which need to be custom made, and therefore by local production the turnaround time dropped from 2 to 3 weeks for imported oligos at that time to 1 or 2 days. This of course allowed to accelerate research output for our customers that apply PC amplification and DNA sequencing in their research. and more recently, it allowed uninterrupted essential supply during the pandemic. In addition, we aim to offer Sanger DNA sequencing services. The aim was here that outsourcing DNA samples for sequencing will allow our customers to save the investments in capital-intensive sequencing instruments. 20 years later, we still do all these services, but of course the technologies in life sciences have significantly evolved in the past 20 years, and so has Inaba Biotech. A big thank you to all our customers, our dedicated current and former employees and commercial partners over all these years, and of course our investors that took the risk and made this possible in 2002. Please enjoy this video about the different aspects of Inaba Biotech. Let us know your comments, suggestions or questions about Inaba Biotech in the comment section below. We strive to even be better in the next 20 years.
Human beings have been using astronomical tools to adventure into the infinite universe, to explore the infinitesimal by making use of life science tools and technology. Founded in 2016, headquartered in Shenzhen, China, MGI is committed to building core tools and technology to lead life science through intelligent innovation. MGI has established 7 international R&D and production centers and is mainly involved in 3 key business segments, including genetic sequencers, laboratory automation, and new business. Continuing heavy investment in R&D, MGI has developed a full range of patented technologies, including DNB-seq sequencing technology, patent array technology, and sequencer optoelectromechanical system technology. Gene sequencing has a very high barrier to entry as it involves multiple fields, including optics, mechanics, electronics, fluid dynamics, molecular biology, chemistry, nanoscience, and other disciplines. MGI is one of few companies in the world that have the ability to develop and mass-produce low, medium, and high-throughput clinical gene sequencers from GB to TB. Besides gene sequencing, MGI has also developed a series of core technologies, including library preparation and automated sample processing. Expanding into new business, MGI has developed multiple innovative life science tools and technology, including portable single-cell systems, remote robotic ultrasound systems, BIT products and low-temperature storage products, with a strong focus on the upstream of the industry. MGI operates in more than 100 countries and regions, serving more than 2,800 customers to date, empowering the downstream customers in reproductive health, precision cancer diagnosis and treatment, infectious diseases, food security, agriculture, forestry, fishing, and consumer genomics. Since the establishment, MGI is driven to disrupt the status quo and accelerate the industry innovation. MGI aims to build a suite of life science core tools to address the fundamental questions, push the limits of science and technology, and lead the innovation in the era of life.
QIAGEN.
Sample to insight.
Introducing the newest member of the QuantStudio family, the Applied Biosystems QuantStudio Absolute Q digital PCR system from Thermo Fisher Scientific. This fast and easy-to-use digital PCR solution offers high-quality data with minimal hands-on time. Sample prep is identical to qPCR. Simply load your reaction into the plate and insert the plate into the instrument. All components of digital PCR, including reagent compartmentalization, thermal cycling, and data collection, are performed on the single standalone instrument. After loading your plate, start your run and return in 90 minutes for sensitive, accurate, and precise quantification of your targets. The quantitation accuracy for any digital PCR system is driven by the amount of sample that is analyzed in a reaction, and while some digital PCR platforms can waste up to 75% of your sample, the QuantStudio Absolute Q system consistently analyzes over 95% so that you can see the whole picture every time. At the heart of the QuantStudio Absolute Q digital PCR system is the novel microfluidic array plate technology. This technology was developed for maximum consistency and accuracy by minimizing waste and maximizing reagent distribution into microchambers. And all you need is one plate and one instrument. The MAP16 digital PCR plate provides reliable consistency, high accuracy, and an easy workflow. After loading your sample into the plate, the instrument performs automated reagent distribution into fixed microchambers. Each reaction remains independent during thermal cycling. 4 optical channels allows you to analyze more targets per sample. As the only digital PCR solution with the capabilities for pre- and post-PCR background subtraction, the QuantStudio Absolute Q system employs sophisticated rejection of non-PCR artifacts, offering high confidence in true positives for every microreaction. The MAP plate is designed to run up to 16 samples in parallel, with the flexibility to run as few as 4 at a time to match experimental needs without wasting partial plates. The intuitive QuantStudio Absolute Q analysis software enables users to easily change and define experiment-specific parameters, name and track experiment details, and monitor the run from an easy-to-understand user interface. After the run is complete, return to view the results and apply powerful analysis software. QuantStudio Absolute Q digital PCR system from Thermo Fisher Scientific. Experience the future of digital PCR at thermofisher.com/absoluteq.